Okay, this problem tests MINM competency 4, and it goes like this. Given that ABC, the product ABC is not 0, so A times B times C is not 0, find all values of x in terms of ABC such that ABCX is singular. All right, so go ahead and pause the video, see if you can do the problem, and then come back and watch my solution. All right, so let's go ahead and do the solution. I think I'm actually going to put the solution down lower, so if you do end up doing this problem on your own and doing it from the notebook, that you won't see the solution when you open the notebook. All right, so the problem is find all values find x such that ABCX is singular. Okay, so what's it doing for me? Okay, let me go back down again. Okay. All right, now ABCX, why is it doing that? Okay, so let's consider ABCX is singular if and only if ABCX is not invertible. All right, that's one of the equivalent conditions for singular. Non-singular is invertible. Singular is non-invertible. Okay. So what does that mean? That means that 1 over, remember this formula, minus BC times DA minus B minus C is not defined. Okay, because if I can define this these expressions, then I have an inverse for this. I'm sorry, this should not be D. This should be X. Sorry, I'm so used to doing D there. But this is going to be X, right? Because this is the formula for the inverse of this matrix. So if I can define the inverse using this formula, then ABCX will be invertible. So if it's not invertible, I can't define this formula. Now the only way that can happen is for this denominator to be 0. That's the only way this formula can fail. So that's AX minus BC is equal to 0. So that's true if and only if X equals BC over A. Now notice that the condition that ABC was not equal to 0 is used here. So recall that ABC is not 0, so in particular A is not 0. So if A is not 0, then I could define X as BC over A. So that's actually the answer. X equals BC over A. That's the value of X that makes this matrix singular. Right? And that's the only value because it has to satisfy this equation. All right, so that's it.